Okay, so we're going to talk about a really fascinating new way to tackle carbon dioxide. But here's the twist. This story doesn't start in the atmosphere or with some giant industrial plant. Nope. It starts right here inside your home with a tiny machine that could literally change the air you breathe.
To really get what's going on, we have to zoom way, way in. I'm talking about the very room you're sitting in right now, because there's something happening with the air in here that you can definitely feel, even if you can't see it. You ever have that feeling? You've been working or studying in a room for a while, windows are closed, and you just start to feel sluggish, a little foggy. Maybe it's just hard to concentrate. Well, it turns out that feeling isn't just in your head, it's in the air. Check out this number. Fresh air outside has about 420 parts per million of carbon dioxide. But in a sealed room with people in it, that level can absolutely skyrocket past 1,500 ppm. I mean, that's more than 3 times the concentration. It's kind of wild when you think about it. And look, this isn't just about the air feeling a little stale. No. Research actually shows that once CO2 levels get past that 1,000 ppm threshold, our cognitive function can start to decline. It literally makes it harder to think clearly, to focus, and to get stuff done. So this leads to a pretty obvious question, right? If this is a known issue, why can't you just go online and buy a little device to fix it? You can find air purifiers for dust and allergens all day long, but not for CO2. And the reason for that lies in how we currently capture carbon on a massive scale. The current big solution is called direct air capture, or DAC, and it absolutely works. These are powerful, incredible technologies designed to literally pull CO2 right out of the atmosphere. But they are built to be Goliaths, not something you'd put on your desk. And when I say the scale is a problem, I really mean it. Take a look. The Orca plant, that's up to $20 million just to capture 4,000 tons a year. The next big project, Stratos, is estimated to cost $1 billion. These are massive industrial projects, not home appliances. And the cost is just staggering. We are talking $600 to $1,000 for every single ton of CO2 they capture and store. This whole model, its cost, its size, its energy needs, it's just fundamentally incompatible with you and me. It's left this huge gap in the market for a personal solution. Okay, so this is where a completely different approach comes in. It's a radical new idea called ChalkDrop, and it basically flips the entire equation right on its head. We're moving from massive and centralized to tiny and distributed. At the heart of ChalkDrop is this really simple, super elegant chemistry. It uses calcium hydroxide, which is basically just common lime, the same stuff used in mortar, and it reacts with the carbon dioxide in the air. And the result? Calcium carbonate, or simple, totally harmless chalk and a little bit of water. That's it. And the process is just beautifully straightforward. A small fan pulls your room's air in. That air flows over the calcium hydroxide, which just grabs onto the CO2 molecules. And what's left behind is inert chalk. No complex filters, no subscriptions, just basic chemistry and a little bit of airflow. And you know what? It's surprisingly effective for its size. In theory, just 1 pound of the lime media can capture about 0.6 pounds of CO2. It acts like an active CO2 trimmer, constantly working in the background to pull down those peak CO2 levels in your personal space. But honestly, the technology might not even be the most radical part of this story. What's truly different, what's a total game changer, is the philosophy behind how this whole idea is being released into the world. You know the traditional way new tech gets launched, right? You raise venture capital, you protect it with a bunch of patents, and you try to sell a product. Well, ChalkDrop is doing the exact opposite. It's relying on people power. It's going to be completely open source, and it's being framed as a movement to join, not just a product to buy. This quote right here just captures the driving belief behind the project perfectly. The goal isn't just to create another company, it's to spark a community-driven movement. And this is a truly grassroots effort. I mean, this isn't some massive corporation. The entire project is the work of one mechanical engineer, Brian, and his AI partner, Nova. It's a classic David versus Goliath story for the modern age. So this all builds to a really unique call to action. The team isn't asking for pre-orders. They're asking you to cast a vote with just $1 to prove that this is an idea that deserves to exist. The goal is to raise $10,000. And to do that, they need 10,000 backers to say, Yes, this idea is worth pursuing.
And here is the most remarkable part. All it takes to be one of them is a single dollar. No tiers, no merch, no upsells, just pure participation to send a message. And the promise is crystal clear. If the goal is hit, a permanent website will be built like a digital monument with every single backer's name on it. The funds will go toward building a real, working prototype, and then, and this is the key, all of the design files will be released to the public, open source, for anyone to build, to modify, and to improve upon.
This leaves us with a really fascinating question. We're so used to thinking that solving big problems requires these massive, expensive, centralized solutions. But ChalkDrop proposes a completely different path. What if real change doesn't come from $1 billion project, but from millions of tiny, accessible, and open ones? What if the next big thing is actually something small?